Now, the third video for chapter 14, section 4. Earlier, we have a video for permutation and a video for combination. And this is the third video. Using the combination concept, we can develop the binomial theorem. Now, binomial theorem formula here pretty obvious, but I would like to explain why the formula looks like this. Okay, and why our formula is the combination, is the choice. So when you are talking about combination, then we are talking about choice. Okay, so why is the choice? Understandable. A plus b nth degree. If we're talking about, for example, if we have fourth degree, then it means a plus b times a plus b times a plus b times a plus b. Now, if less than 3 degree, you may use non-multiplication. You can calculate. But if you have higher than 4 degree, you probably want to use concept with formula. We just want to learn, and then we can easily write down the answer. Okay. So if we directly want to use the concept without multiply, keep going and multiply, then we think about if you have 4 degree here, means you have 4 binomial to multiply. Now this 4 multiply 1, 2, 3, 4. So we are talking about the choice. The highest degree of A is you choose A multiply A multiply A multiply A, right? So, but how many choices we can think about it? But it will be the highest degree possible is 4 degree. Now, when you choose all the A's from each parameters, each polynomial you want to each binomial, you choose A from first one, choose A, choose A, choose A, means you don't choose B, so it's 0, right? And we are thinking about how many choices here. And then you may choose 3A and 1B. So here you may choose A, choose A, choose A, and the last one you don't choose A, you choose B. That's possible. So you choose 1B. But this B, maybe you choose B here, you choose B, or you may choose B from here. You may choose B from here, you may choose B. So you have 4 choices. So actually you have 4 choices here. And if you choose all the A for each binomial, actually you have only one choice. And keep going. How about A squared, B squared? Is 4 degree, right? So A squared, B squared, what's the number? And then A, B cubed plus, what's the number? A0, you choose all the B's. Okay. So here, there's no permutation needed. If you choose this one multiply with this one, you don't need to multiply back and forth. So A multiply A, you don't need to say, oh, this A multiply the A again. No. So order doesn't matter. Which one first? It doesn't matter as long as the choice. You choose this 3A to multiply and this B. That is one choice, right? Or you may choose this 3A and this B. That's one choice. But for each choice, you may have B, A. It's same as what? This is just one choice. Okay? You don't do permutation. You don't. And when you choose this A, you have A, B. It's just one choice already. If you do permutation, you may end up with the other one. So basically, there's no permutation need. You only need the combination. So in other words, we are talking about you may choose A1, A2, A3, and then B4. And you don't do permutation because this is one choice. And another type of choice, you may say, I choose B1 and A2, A3, A4. That's one choice. You don't need to do the permutation. And A1, A2, A3 are A, same thing. So because A1 equals to A2 equals to A3, that's another idea you can think. The concept is why you don't do permutation. Because A1 equals to A2 equals to A3. Okay. Now, so since we are not going to do permutation, basically, out of 4, you choose 2B. Out of 4, you choose 3B. Out of 4, you choose 4B. And here, out of 4, you choose 1B. Out of 4, you choose 0B. Because you choose all the A's, means you choose 0B. So the formula you want to follow 4, 3, 2, 1, 0, or you want to follow the B's degree 0, 1, 2, 3, 4. All the publisher would like to follow the exponent of the B exponent. So start from 0 and then 1, 2, 3, 4. So it looks better for the formula. So when you have talking about the nth degree, then first you choose all the A's, means you don't choose B, and then you choose B, you choose 2B, choose MB. And this is the combination. Combination is you 4 choose 0, 4 choose 1, 4 choose 2, and we learned earlier the combination formula. You can use it. Okay. Now, so I think that as long as you went through permutation concept, combination concept, but binomial theory is easy. Now, next, I want to help you with how you set up binomial formula. Okay. So see if you have a question, ask you to do how many degree, let me see. Okay. Say if I ask you to find the x plus 5 to the 6th degree. Wow, very big number, right? So x is a. X is a. And 5 is b. Now how you set up your formula? Let me show you. So first, how many choice? 6 choose 0. Okay, and then you have x 6 b 0, not a b. Right now you have 5, right? So you have 5. 5 0 plus 6 choose. Let me make it smaller for save space. Six choose 1 means x you only choose 5, and the 5 you choose 1. Okay, but let me start all over to show you if on the test, what's the best way to show the work. So earlier, right now I'm just showing you the concept for the example. But if I'm doing this homework, this question, I will set up this, parentheses with x6 plus parentheses with x5 plus parentheses with x4 plus parentheses with x3 plus parentheses with x2. Oh, I want to save space, so let me retry to make enough space. Looks better. Okay. So let me do this a little smaller. X6 plus still 6, but I choose 5 plus still 6, but I choose 4. And I leave space for 5. Okay. 6 x3 6 x squared 6 x plus 6, and x is 0 degree, right? Now, next, I need to have 5. 5 start from 0, 1, 2, 3, 4, 5, 6. Agree writing. Okay, so 0 plus 6 is 6. 1 plus 5 is 6. All the degree together need to be 6 degree. You need to double check. 6, 6, 6, 6, 6. Oh, this is 1, and then this is 6. Okay. 1 here. Okay. So every term totally is 6 degree. And then the choice, I follow the blue color. 0, 1, 2, 3, 4, 5, 6. And then you use formula. You use calculator, or you use a formula to calculate. And also you need to simplify. This number is 1. This number is 5. This is 25. You need to multiply with this number. Okay. Okay, and keep going. Very complicated, but pretty soon I'm going to show you a shortcut. Okay, so you will like the shortcut. So you will simplify and keep going, but let me dip up to here. And right now I'm going to show you a shortcut, and then go back. We can finish this one with shortcut easier. Okay. So even though we can deal with higher degree, we can have a little easier way. Okay. Now, before I leave this page, let me show you the formula I listed here. This one, they look the same, right? Just we use a sigma notation. So this is n. If this is k, then this is n minus k. Make sense? And n minus k plus k equals to n. These two together is n. So this is how you use a sigma notation, and you set up this number is k. The k follow b degree. So you can use this one, this idea. Okay, this happen to be the formula here, the case term. Case term will be the formula for your sigma notation, and the case start from 0. That's very important. Case start from 0 to n. From 0 to n. So this is the case term. Case term. Okay. Now we learned this from our previous videos. So that's easy. The hardest one will be this formula. Oh, is this the case term? I think I made a mistake here. See, I said this is case term. I was wrong. N choose K, B case degree, but how many terms? First term, you have K equal to 0. When K equal to 0 is the first term. When K equals to 1 is already second term. When K equal to 2, you plus 1. When K equal to K, you have K plus 1's term. That's very important. So let me erase all the marks so you can see better. So the formula in general, very easy to understand, is just the choices. So the hardest part is for each term, how you calculate with the coefficient for each term. And sometimes the question is not going to ask you to list every terms here. So you may be asked to find the case term. Case term, this is first term, second term, third term. So the case term supposed to be, if I'm talking about case term, this number need to be k minus 1. So case term is here for k minus 1. So this is case term. When you n choose k is k plus 1 term. Okay, so this is not case term, this is k minus 1 term. Be careful. Now, let me give an example. How about if I ask you to find the fourth term? Fourth term, this number 1, number 2, number 3, number 4. Fourth term is 6 choose 3 s cubed. So the fourth term is 6 choose 3 times 125 times s cubed. If they only ask you for this term, then you only need to calculate this number. You don't need to worry about other terms. Now, again, I'm going to go to next page and show you how can I Do I have a shortcut to fill in the coefficient here? Yes. Okay, there's a shortcut. Let's keep going to next page. We have a Pascal's triangle. Pascal's triangle, they give you all the possible coefficients. So when you have 0 degree, everything is 1. 1 degree is a plus b, obvious, right? So I think they write down something wrong. A0, B1. Okay, so it's a plus b. And then a plus b squared, we memorize the formula before. A squared plus b squared plus 2ab. Yes. And I think I gave the class the cube, the third degree formula. It's a cube, b cube, and then 3a squared b, 3a b squared. I gave the class this formula before. Now, for the fourth degree, someone calculated for us, and keep going. Mathematician already have a formula for us. And your job right now is, if you learn how to make a Pascal triangles, then you can easily figure out what's the, like for example, let me show you. If I say n equals to 6, then I have a plus b to the 6th degree, then I can easily write down the answer. A6 and the a, well, I have no space. If I have, let me write down the bigger space here. Okay, I'm not going to write down because of what? This is what we want to figure out. 6th degree, right? If I had a plus b. So if I change to a plus b, that's why we want to find the coefficient here. Oh, sorry. Computer run very fast. Okay. So before we keep going, let me show you very interesting thing is the coefficient 1, 1. We make it here. Okay, 1, 1. Coefficient 1, 2, 1. We make it 1, 2, 1. We just copy our result. 1, 3, 3, 1. 1, 3, 3, 1. And then 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Why are we doing that? 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay. So let me erase all the extra marker here and show you why mathematician did that and what did they discover. Okay, so since the only thing we care is the coefficient, and after we find out the coefficient, then we can just, if b is 5, then b is 5. We keep going on calculating. If a is 1,000, then we change a to 1,000. But that's after we find out what's the coefficient first. Okay. Now, so this is not a formal proof. This will be just the logical reasoning, okay, without proof. And if you need a formal proof, you can find from other information, but not here, okay? Now, before I keep going, I want to show you the coefficient. Remember, we talk about the coefficient is the choices. Again, I need to go back. The coefficient is all the choices combination. Okay, and right now, if we don't write down 1, 1, 1, and 1, 2, 1, if you don't write down, actually this 1, okay, and the coefficient is 1 and this 1, right? And the coefficient for the second degree, so this is 0 degree, first degree, second degree, you have 1 and 1. So that's the formula. Okay, and the middle is 2, right? That's the coefficient. And for the third degree, you have 1 and 1, 1 and 1, and this is 3. Okay, and keep going, it will be similar. That's 1. For the fourth degree, 1 and 1, and then 4, 6, 4, 4, 6, 4. That's the combination, and keep going, keep going. Now again, I want to tell you because we pretend we developed the formula up to here. If you want to memorize, probably not too hard. But how about the next one? I didn't give you formula. How can you keep going? So right now I'm giving you a very important secret here. So we go back to the coefficient only. So 1, 1, 1, 1, 1 is always, okay? 1, 1, 1, 1, 1 is always. It's always 1 outside the triangle. And then this comes to magic. Pay attention. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3, 4. 3 plus 1, 4. 3 plus 3, 6. 1 plus 4, 4 plus 1, 6 plus 4, 4 plus 6, 10. I will say mathematicians, they are so smart. I didn't invent this. I didn't discover this, okay? But there's some genius that discovered it. And they guarantee 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. This 15 and 6. So right now, I can tell you the coefficient here, which will be 1. Let me write down all the number, all the terms here. So if I write down, I make it smaller. Okay. So if I have a cube, no, not cube, a6, and then a5, and then a4, a3, a2. I don't need to write down this small. Let me write down a little bigger. So first, after you find out the coefficient, you need to set up the formula, right? This is 6 degree. I keep going on that. 6 degree, and then I will have 5 degree, and then 4 degree, 3 degree, 2 degree, 1 degree, and 0 degree. So I have B6, B5, B4, B3, B2, B, and no B. Okay, I said B0. Okay, so I almost done here, and I put a plus. And the last thing I need will be the coefficient. So I found out my coefficient from the Pascal triangle. 1, 6, 15, 20, 15, 6, 1. So 1, 6, so 1, 1, 6, 6, always symmetric. 15, 15, and in the middle you have 20. So I'm done with this is the A plus B to the 6th degree. Okay, so n equals to 6. So if you had this coefficient 1, 6, 15, 20, 15, then you can go back to here. This is 1. Let me make a bigger size of the font. Okay, so I have 1, and then 6, 15, and then 20. So this is 20, and then you multiply them all together, and then keep going. This is 15, 625x fourth, plus this will be 6. Wow, this even bigger number. I don't know how many x. Okay, and the plus that's 1 x6. So if you want to do it by formula and calculate, that's fine. But if the degree is not too high, I will suggest you use Pascal's triangle. Now, understandable, if you want to go to 1000 degree, then I don't know which one will be easier. Okay, but if they only ask you for one term, for example, if they ask you for the k minus 1 term, or k plus 1 term, if this is k and this is 1, right? So 1 plus k, this k plus 1 term, did I say wrong? Earlier when you had k, this means k plus 1 term. I did wrong here, right? That's k plus 1 term. Sorry about that. Okay, because first term is 0. And when you have k here is k plus 1. Yeah, this part I did right? And the k term will be here. And when you have choose k, then there's k plus 1 term. So when you have choose k, this is k plus 1 term. I just feel something I did maybe did wrong. Okay, so this formula easy for me to make a mistake. I don't say I'm confused, but easy to make a mistake. Okay, so the n choose k, a n minus k, b k is the n is the k plus 1 term. Okay, so if they only ask you for one term, then you can use formula if you want. You don't need to go through, wow, so many layers. I will give up anyway. Okay, so this Pascal's triangle, and if you are not tired, you want to keep going, you may keep going if you want. Keep going till you feel tired. So I'm done with chapter Algebra 2, chapter 14, session 4. And this session we went through a lot of different information. The most important thing in the end called binomial theorem. It will allow us to multiply binomial to the nth degree. That's very fancy formula. I like this formula. Okay, and it involves statistic counting principle. It's really fun. I think it's very useful for you if you want to keep going to pre-calculus, calculus, or take a statistic. They are all very useful for you to learn. Okay, so I think this is my very last video for Algebra 2. So thank you for your watching. Bye bye.